We will complete our previous example copper with nitric acid for HNO3 to produce copper nitrate, CuNO3O2 plus copper nitrate plus 2NO2 plus 2H2O. We will discuss the copper. We will take two half reactions. First, we will begin with copper. It changes into, if we calculate the oxidation number for copper here, it will be positive 2. Here it will be 0, from 0 to copper positive 2. So plus 2 electrons, that is oxidation half reaction. We call that oxidation half reaction. Oxidation half reaction. And what about reduction half reaction? We will find that here in nitrate 2NO3 in nitric acid, that nitrogen is positive 5. Change it into 2NO3 plus 2 electrons plus 4H of the acid positive, so it produces 2NO2 plus 2H2O. We will observe that here nitrogen is positive 4, since the oxygen is negative 2, nitrogen will be positive 4. So this is my reduction half reaction. If we add these two reactions to each other, we will see in the addition of them to each other. So copper 0 plus 2NO3 positive 5, so that's nitrate, plus 4H positive, it will produce copper positive 2 plus 2NO2 plus 2H2O. So it is the net reaction. It is called redox reaction. That is my redox reaction as in the paper. Since the copper is oxidized and nitrogen is reduced. Copper is oxidized from 0 to copper positive 2, and nitrogen from positive 5 to nitrogen positive 4. So copper is oxidized and nitrogen is reduced, as we see. We will solve some examples in the formative assessment, page 607. You will find that in the formative assessment number 1, what differentiate an oxidation reduction reaction from other types, such as precipitation reaction or something, or acid-base reaction. In oxidation, you must know that. Very important point. Number 1. Oxidation reduction, there is a change in the oxidation state. In the oxidation reduction reaction, there is change. If you calculate, as we know before, there is a change in oxidation states or oxidation number. Oxidation states, it means the value of oxidation numbers. There must be a change. If it is 0 and it change into positive value, so it is oxidation. If it is negative any x, change it into 0 and change it into positive x, so it is oxidation. Why? Because the oxidation state increases. If it is positive x, an element on it, an oxidation value positive x became 0 or became negative x, so it is a reduction for the element. So I can consider that a rule, and we can consider that a rule from negative x to 0 to positive x, or from negative x to 0 or to negative x, so is oxidation or reduction. So the answer of number 1 what differentiates an oxidation reduction reaction? There are change in the oxidation states or oxidation values. I can solve with you number 2, label each of the following half reaction as either oxidation or reduction half reaction. I have number 2 in the formative assessment, bromine there are 2 plus 2 electrons, it changes into 2Br negative. So it is from 0, I know that element is 0 to negative, so it is a reduction. It is a reduction half reaction because gaining electrons. It is a reduction. We can solve it easily. Number B, Na to Na positive plus electron, so it is easy, it is oxidation. The previous one is reduction because gaining electron, but that one is oxidation because losing electron. Number C, the last one, 2Cl negative, change it into Cl2 plus 2 electrons, Cl2 plus 2 electrons. Also that is oxidation because losing electrons is oxidation, but gaining electron is reduction. The first one, A, is reduction, B and C is oxidation. We will solve the last example is number 3. Which of the following equations represent redox reaction? Number 3A, I have KNO3. My potassium nitrate solid, change it into potassium nitrite, KNO2 plus O2 gas. So that if we calculate nitrogen here, positive 1, potassium, oxygen here, potassium positive 1, oxygen negative 2, nitrogen will be X. So my X will be, that will be negative 6, and that will be positive 1, so my X will be positive 5. So that's my X, positive 5. Here, potassium positive 1, oxygen is negative 2, so negative 4, and positive 1, so it will be positive 3. My X here will be nitrogen. So nitrogen from positive 5 to positive 3, so the oxidation state or oxidation number decrease, so it is reduction. The oxidation number is decreased, so it is a reduction for reduction of reaction. And it is a redox reaction also. And what about the oxygen? The oxygen here is negative 2, and that oxygen is negative 2, nothing. Negative 2, nothing will occur. But negative 2 to 0, so it is my oxidation. So oxygen from negative 2 to oxygen, here an element, because it is an element, not in a compound. Oxygen element O2 is 0, so from negative 2 to 0 is oxidation, because increase in the oxidation number or oxidation state. It's very important redox. So that reaction is a redox reaction. That reaction, I can call it a redox reaction. Why? Because oxidation occurs to oxygen and reduction occurs to nitrogen. Also, we can move to another example. We can go to number C. Number C, sodium hydroxide in NaOH plus HCl, it produces NaCl and H2O. NaCl and H2O. Acid plus base gives salt plus water. Sodium hydroxide aqueous, hydrochloric acid aqueous, sodium chloride aqueous plus water liquid. You know that. And the charge here positive 1, hydroxide negative 1, hydrogen positive 1, chloride negative 1, positive 1, chloride negative 1. So positive 1, hydrogen negative 2. So there is no change in oxidation states or oxidation numbers, so it is not redox reaction. It is not oxidation or reduction reaction. So